In this video, we're going to discuss phase shift of a sine and a cosine graph. We're actually going to go to the next tab here. And a phase shift is really like a horizontal shift. But don't forget the basics. Here's the basic sine function with these values of x, which are really just the 90s of our triangles, and the 90-degree angles around our unit circle. And so that's where we get the sine of those 5 angles and the cosine of those 5 angles as well by looking at our 90-degree angles. So don't forget where the basics came from. And what's going to happen here is if there is something inside the parentheses with the x, so that's what it says. All of these so far have had a phase shift or a horizontal shift of 0 because there has been nothing inside the parentheses with x. So if there is subtraction, let's say we're subtracting some number from x in the parentheses, we are going to have a phase shift to the right. You may remember that because if you think about transforming a quadratic, let's say we had y equals x minus 3 squared plus 4, for example, we know that minus 3 moves our vertex 3 to the right. And so the same thing will happen here with our phase shift in these sine and cosine graphs. We see subtraction, we're going to shift it to the right. Conversely, when we see addition, we're going to phase shift our function to the left. Now, to figure out exactly how far the function will move right or left, we're going to divide the number being subtracted or added by the coefficient of x. So we actually have two things to do here. So for example, in this function, we see it's a sine function, and we have this number being subtracted from x inside the parentheses. First of all, the fact that it's subtraction means we're going to move to the right, and exactly how far means we find out by taking that number we're subtracting, pi, and dividing it by the coefficient of x, which in this case is 1. So our phase shift is pi to the right. And that's as easy as that. So we know that it's going to move to the right pi. So let's go down to the actual example here. We'll start with our basic function, and we've got that already. Now we should recognize this pi, this minus pi, means we're going to move pi to the right. Which coordinate is affected if we're going to move to the right? It's the x-coordinate. And so each of our x-coordinates is going to move pi to the right. So that's actually, we're going to add pi to all of our x's. So 0 plus pi equals pi. Pi over 2 plus pi. We'll need a common denominator here because we've got a fraction. So if this is pi over 1, I can make it 2 pi over 2. And when I add those, I end up getting 1 plus 2 is 3 in the numerator, 3 pi in the numerator, and 2 in the denominator. And so there's our next x. Then we have pi, and we're going to move it pi to the right. That leads us to 2 pi. We'll finish soon here. We got 3 pi over 2 plus pi. And again, we'll need that common denominator, so we can put it over 1, and a common denominator would be 2, so we'll put 2 pi halves, which is really just a whole pi is what we had. So then we get 5 pi over 2, and then lastly we've got 2 pi plus pi. That leads us to 3 pi. So those are our x's in this situation. Our y's did not change at all because we're moving left and right, not up or down. And so we've got these 5 coordinates at 0, or we're no longer starting at 0, we're starting at pi. We've got a coordinate at pi 0. And then at 3 pi over 2, we're up to 1. At 2 pi, we're at 0. At 5 pi over 2, we're at negative 1. And at 3 pi, we are at 0. So these are our 5 coordinates here, and as you can see, it really is just the original function moved 3 to the right. This point here moved 3 to the right to get over there. So we really have phase shifted our whole function. Here's our 5 points. Remember, of course, the function does go on, and so it would continue to do this forever, but we've got one full cycle here, and that is mainly what I'm going to be looking for, is the one full cycle. Okay, so let's try one with cosine. This time, again, there's going to be a movement to the right because we have a subtraction inside the parentheses with the x. And as far as how far it goes, phase shift, don't forget, is that number we're subtracting, pi over 2, divided by the coefficient of x, which again in this case is 1, so we have a phase shift of pi over 2 to the right. So here's our basic cosine graph. Our y's will not be affected again. We had no change that would affect any of our y's, so we're going to focus only on our x's. And so we'll go 0 plus pi over 2, and that's going to just be pi over 2. I'm going to erase my y's for a second because I may need more space than I've left myself. So we're at pi over 2, and that'll be where the 1 is this time. Then we'll have pi over 2. Move it pi over 2 to the right means we're going to add pi over 2 to our x. That ends up being 2 pi over 2, which is really just going to be pi. Another way you could look at that is really we have a half of a pi, add them, you get a whole pi. Still another way you could look at it is 90 degrees plus 90 degrees equals 180 degrees. So either way, we get pi as our x coordinate there. The next part is going to be to take pi and add pi over 2. We'll have to get a common denominator here, so I'll throw in that makes pi over 1, and I can make that into 2 pi over 2, so this is going to be 3 pi over 2, negative 1. Then we have 3 pi over 2, move it pi over 2 to the right, we get 4 pi over 2, which is just going to be 2 pi. And lastly, we've got 2 pi, moving that pi over 2 to the right. So let's get a common denominator. I would need to make that 4 pi over 2. So that adds together, gives me 5 pi over 2 at 1. So these are my 5 coordinates. Let's go over here, and we need to put pi over 2 and 1, and then pi was 0. 3 pi over 2 was negative 1. 2 pi was back to 0, and 5 pi over 2 was 1. And so everything is just shifted, and you can see it really easy on this graph that everything is shifted to the right by pi over 2. Here's our 5 coordinates, and we are done with that phase shift. Now the last one here is we're going to go ahead and take care of something where we have both a change in y and a change in x. You should recognize that we have an amplitude that is going to double all of our y's, and then a subtraction of 3, which will be a vertical shift, which will shift all of our y's down 3. So let's take care of those first. Just go ahead and grab these x's, put them over here, and it's going to have us, the 2 out front will just have us double all of our y's. And so let's just double the y, 2, 0, negative 2, 0, 2. And we'll go back over here. Let's move everybody down 3. And again, moving down 3 is only going to affect our y's. It's not going to affect our x's. So this is negative 1, negative 3, negative 5, negative 3, negative 1. And now we can deal with the idea that we do have a phase shift here. We have a phase shift that is going to be pi divided by the coefficient of x, which is 1, so we're going to move pi to the right. That will cause us to add pi to all of our x's. We've actually done that once already, so I'm not going to go through how we get all those x's. You can look up above to see how when we move everything pi to the right, 0 plus pi is pi, pi over 2 plus pi is 3 pi over 2, pi plus pi is 2 pi, 3 pi over 2 plus pi is 5 pi over 2, and then 2 pi plus pi puts us at 3 pi. And our x's, or our y's go negative 1, negative 3, negative 5, negative 3, and negative 1. So let's get the graph on this one. Pi, we're at negative 1. At 3 pi over 2, we're at negative 3. At 2 pi, we're at negative 5. Gosh, I hope this was a cosine graph. Okay, it was. 2 pi, we're at no, that doesn't have 2 in front of it. There was pi, so this was 2 pi. At 2 pi, we're at negative 5. At 5 pi over 2, we're at negative 3. And then at 3 pi, we're at negative 1. And so here's our little cosine graph. it's been shifted to the right by pi, it's been stretched vertically by 2, and everybody's been moved down by 3. So our final points would be that. And that is how we phase shift sine and cosine graphs. So here's some practice problems you should try on your own.